All right, some early morning streaming with some bed hair. Let's see what we can figure out today. So we got compressed sensing working yesterday. This indicates that the problem's in the indicator function. Okay, I can see the chat. All right. So let's set noise var greater than 0. We're going to make it tiny. Right, just really, really small. So that the result should be the same. We're going to look at GCS and GCS indicator. We're still using n coils equals to 1. That seems right. Not GCS indicator, GDC indicator. GDC indicator. Forgot to announce that we were streaming. Okay. I don't see a bug. Let's see what it does. output argument image. So y here should be the image. That is not at all the same. That's just the least squares reconstruction. Okay, so this is totally broken. So there's another problem that we could try to fix since this one's not working. Like this should always, or rather, this proximal operator should always just project onto that, right? Because the rad's going to be times 10 to the negative 48. I want to take that and compare it to B. The mean is 0.00136446. totally different. That is tiny. Whatever n minus b is, that should project it to basically 0. And then we're going to add b. Why didn't that work? Because we don't have an in yet. Point 0.0059133. 0.0059133, right. I think that's just b. Okay, so now instead of doing a projection, we're actually, we are still doing a projection, but we're projecting as though the noise variance is 0. We'll call this multi-coil. Yeah, okay, so we're going to have to change everything. Maybe not. Maybe I could just do that. You see, this is just this, right? I just replaced it with this. Here, out is always equal to b. So what to do now? So there's a problem that we could make slightly more sophisticated when noise var is 0. So we could minimize psi x subject to mx is equal to b. This is just for debugging. I just want to see if solving this problem gives us the same as solving this problem, which it should. Oops. Let's set the noise variance back to 0. Huh. What? It thinks MTMX is a function handle. Is there a bug in power iteration now? That's strange. X is an array. I'm confused. Oh. Okay. Right. Yeah, what we just did is for debugging. Let's see where this takes us. So now y should be size image. Oh, I forgot the data consistency. Right. We're going to need two functions now. This is going to be complicated. This is equality. This should be equality. And then here we add these things together. And then what? I there means indicator. So G is G1 plus G2. So A is going to be psi. Good morning.
Morning.
I'm going to have to take a break. Okay, so we're back at it. I feel like the code's getting away from me. So by embedding, there's just so much here that's, well, maybe not. I don't know. Tough to say. Let's do some more debugging and see what we find. 645. Okay, so this should solve the same problem as this. With the issue being that it's just closer to this version. Oh my goodness. I forgot that. So this should be closer to this version. And so if this doesn't work, maybe it gives us a clue as to why this doesn't work, but it's simpler. If it does work, then maybe it gives us a clue as to why this doesn't work based on the differences. That's the idea. So here in2 is the image. So this is no longer as simple, is it? Yeah, we actually need to put apply F into NA. Okay. So here, N2 is now N2 is actually the length of B. Here again, it's the length of B. Out 2 is equal to B. We don't actually need that because we're just projecting. All right, let's see how it does. Still just the least squared thing. The least squared answer. There's just nothing to this. Do we actually need G? Is G optional? Or is it just used to calculate the objective values? Do we need an F? Okay, so G is just for objective values. We don't actually need G. This problem can be solved with Douglas Ratchford when psi is the wavelet transform because psi is orthogonal. Oh no, it can't because of this. We're going to make verbose false, and we're going to set the number of iterations equal to 1,000. Does that solve anything? So the next question is, what do we do now? Suppose this doesn't work, which it won't. What do we do? In is size 85197. 85917. It's got the right length. It's a good check. Right. I didn't think I hit continue. I thought I just hit step. Step. Yeah, what's going on now? Just for my own sanity. I'm going to define F here, and prox F. Okay. Let's bring that back down to 1,000 so it doesn't take so long. I was just stepping over this code, but for some reason it was doing continue instead of step. Yet that wasn't the issue. Boy, oh boy. Okay. This is where I was thinking we could do a different code. We're going to call this MRI Recon CS for compressed sensing. Okay. All right. I'm probably going to keep this code in worklib regardless of what happens with Recon SPIRiT. I'm not sure, but I probably will. Okay, so what does this code do? By default, minimizes L2 or the L1 norm of psi x subject to mfx equals b. X of c equals b of c. Where c equals 1, 2, c is the number, is the coil index. Okay. Now here, we've already got this implemented, right? It's this. Doesn't this look familiar? Let's define these functions, and then let's do checks. We need psi, f, inverse, mc, and t. We're going to need m, mc, f, yes! Okay. What do y'all think? Oh, that won't work because we're not calling it. Just going to do that. An unknown. GCS. Oh, right. There's this BCS function somewhere. Okay, so let's do this for a single coil of data. Still figuring out stuff. Power iteration. X naught is required if M is a function handle. X naught. Didn't I do that? N unknown is 0. Because we don't want K data here. We want K samples. Opt-alg optimization algorithm. Got a little farther. Unrecognized function or variable prox f. Okay. Well, our adjoint test is passing. That's always a good thing. y is, the estimate of the number of unknown. So to get the image, okay, that's the result with compressed sensing that we saw before. The compressed sensing is too severe. The artifacts are too severe. I have a question. What is wave split? Okay, it's reasonable. So we can solve this problem. Now let's do it for multiple coils, and I would think that should just work. Check if the adjoint passed. It's taken a long time. All right. Verbose. It's slow. Oh, it's slow because we have so many coils of data, data for so many coils now. Apply MC. What is sample mask? That might work. Okay, so that did work. It's going to be like if not is matrix. This is going to combine the images from the different coils into a single image using the Romer reconstruction. Oh, no. But the way we actually want to do that is with this least squares business. Now we need to apply VS. Which takes apply S. And we're going to start doing all these things in alphabetical order. Already I've messed up because apply F should go before that. I think this is going to work. But the result is bad because we're not allowing these values to change at all. Said differently, we're imposing this too much. Yep, so that's the reconstruction with hard data consistency. And the wordlet artifacts are too severe. Much worse than we were getting long ago with lambda. Nevertheless, we should be able to do this, right? Not enough input arguments? One, two, three, four, five, six, seven. 1, 2, 3, 4, 5, 6, 7. this works on the other code. That's so weird. User supply function failed. Oh, caused by not enough input arguments. Line 180. What am I apply VS? Doesn't it take 2 arguments? How do we handle that over here? Seems to work okay. That does not make sense. Let's do a check for apply VS, which we have over here, but we don't have over there. I made a mistake. Where's do checks? S maps. That's the issue. Okay. So we're going to add a check that if you're passing in data of multiple coils, you've also got to pass in the sensitivity maps. Now we got 2 adjoint checks passing. That's like twice as many as 1. Wait a second. What size is that? 256 by 256 by 8. Apply F. Why does image have size? Oh, because we got to do it here. Okay, and that's the result we got before, basically. A little less noisy. Great, great, great. Now what? If lambda is supplied, then minimizes the L2 norm of MFS x minus b squared 1/2 plus lambda times the L1 norm psi x. When psi is orthogonal, this has a simple proximal operator, and this is differentiable, so we can use Fista. I guess I could say if, yeah. If you supply lambda, then what? Yeah, then you see these two things are not related. Let's do this one. We're just going to do that one. All right, so if numL lambda is greater than 0, else end. Else we do this. Okay. Minimize MFSX minus B lambda times psi x1. So now the question is psi. If psi is equal to default psi, use Vista. Else, or O psi is equal to true. Doesn't have to be the default as long as it's orthogonal. Use PDHD is equal to true. Okay. Use vista is equal to true. Else, if use PDHD equals to true, error unknown optimization method. Okay. Image 0, you say? So Vista minimizes functions of the form f of x plus g of x, where f is differentiable and g is has a simple proximal operator. So for Vista, we need f grad prox g, g. F is equal to 0.5 times norm apply VMFS in minus b squared. Oh, we could just do MFS and then take the Frobenius norm. I keep forgetting that. Oh, this is just going to be 2 anyways because m returns a vector. Okay. And that's f. F grad is equal to at in times what now? Apply MFS in transp minus STFTMT B. Apply MFS in no B transp All right, that's what the gradient is. G is equal to lambda times the sum of the absolute values of psi x. Can't do it. Norm psi in 1. But the problem is that this needs to be a vectorized version of psi in. Said that to do checks. Prox G is equal to what? Prox L1 complex in lambda times T if inputs K data an array of size m by n by c, where c is the number of coils and unclosed data have value 0. Well, inputs. Just want to remember what OSI is. True or false to indicate whether psi is orthogonal or not. Ay, ay, ay. Error using add parameter. Validator must be a function handle. Oh. Okay. Wrong inputs. So what should this be? Why didn't that work, actually? Oh, that's why. Okay. Joint check passed. What? Did I not supply a lambda? I see. Equal sign is not supported for operands of type function. MATLAB, see if function handle is a particular one. String compare. Huh. Let's see if that works. Oh. It's going to have to be MRI Recon CS default side. All right. Looks like that works. We don't have an apply MFS. Okay. Let's change that. I did these the backwards way. We don't have an image 0. Where am I reshaping? So for this problem, x is actually just the size of the image, not the size of the coils, not the size of the data array. That might indicate, I don't know. Okay. Multi-coil. Single coil. Where does psi get set? If n coils greater than 1, else and equals. I wonder if this had something to do with the issue in the SPIRiT regularization. I'm not sure. I don't think so, though, because we weren't doing this data consistency problem. In the multi-coil case, where's default psi multi-coil? Yeah, okay. Still got an issue? B psi. Oh boy. B psi size is equal to if n coils is greater than 1, else end. S. Nope. image. Where's the do checks for psi? Now I got to change it to this. Boy, oh boy, just can't get this correct. Reshape in VC V size. Why? No, this is wrong. Oh, right. This here, X. Okay. The issue is that now psi has two different sizes. Why is this crashing? Because when lambda is supplied, when lambda is supplied, it's not if. If num lambda is greater than 0 and else. This is a part where that agile programming thing sort of comes into play. Like we're having to do stuff like this because we're trying to combine multiple different objectives into one function. And you can see there are trade-offs. Why is it in multi-coil? I think this is the V size in. These are the input sizes. And if you supply one, then you have to supply something that operates on something of the right size. And that's the way it'll be. Okay. Oh, psi. Wow, pretty tough. Okay. Okay. That works for me. Where is V psi? Doesn't have to be. Okay, so psi input size. That makes it look nicer, doesn't it? Okay. And we're running. That looks amazing. Okay. I guess I should have ran it to here. So with PDHG, what happens? Oh, I see. So I can just call this image, right? It still work if lambda is 0, if lambda is not supplied. Wait, did I just changed the wrong code? No, I didn't. Okay, it still runs and generates the image that we liked. Okay. You can see we're going to be at this a while. The next thing we're going to do is add joint sparsity. I'm going to take a break for a while. We'll see how far we get at this the next time we work on it. See you guys later. We're going to do one more stream today. We're going to see if we could get compressed sensing working with joint sparsity. I'm just curious to see if it works or not. So the problem we're going to minimize is this one. And that does not require sensitivity maps. So that check's going away. Let's see what this does. So number lambda is going to be 0. We're not going to supply lambda. And we're not going to supply sensitivity maps. So this is if n coils is equal to 1, then do this. Else end. Okay, so then the problem we're going to minimize is I like the way this works where I can create, all these functions that then we just define the functions f and g based on the functions we previously created. Then we call the optimization, and the code does different things based on what information it has. I like that. It's nice. Okay, so we're going to do this subject to indicator function mf minus c is equal to 0. Without any. Okay. This has a very simple proximal order. And this, oh no, it's back to that. No, it doesn't. Okay, so G. What is G? Apply A is equal to concat psi mf. Unrecognized function or variable, apply mf. Concat psi mf. Okay. All right, it passes. Great. So we're about to have apply A. T is equal to at in norm L2, L1, right? In, what are the inputs? Oh, the weights, okay. Now here, G really does need to be something of size SK data. So I'm not sure I need that, but we're going to have it there just in case I do. Hopefully we'll remember to check, but if we don't, it'll work. Okay, prox, whoa, plus the indicator function of So now we need in1 and in2. How have I been doing that over here? I've been creating different GCSs, haven't I? But there needs to be an indicator function here, doesn't there? I'm not sure. This code's all weird to me now. Oh, I see. No, we've been... Wait, what? See, GDC plus. Oh, and then I have the ins right here. Okay. Well, numl, I guess it's nk data. N2 is equal to MB. In from 1 to N1. NK data plus MB. N1 plus 1 to N2. Okay. Prox G at NT. Prox L2, L1. Yep, L2, L1. From 1 to N1 T. These are going to get concatenated. So what's the output of this going to be? This needs to be reshaped. SK data. I think I have to reshape this. I don't know. Let's find out. So the indicator function. This is either 0 or infinity. Oh no, so the proximal operator. Huh. So this is a projection. So we'll call it project hard data consistency. How did we do this before? We didn't. Project hard data consistency. In from n1 plus 1 to n2. In sample mask equals 1 is equal to b. That's the projection. Oh, out equals in, out sample mask equals 1. So I think I can do it like this, actually. Because it does a, MATLAB passes by copy. What are the two? Pass by reference or pass by reference or pass by value. You could just call it pass in a copy, pass in a reference or pass in a copy. And this is pass in a copy. So we can just do this. It doesn't affect the thing that gets passed in, and that is great. And now we do that. Oh no, this should just be B. Because this is after we've applied MF. Okay. X equals zeros S image and use PDHG. Okay. I think I just coded up this. So let's see if it works. Optimization method. Oh, and it actually say it equals true. Okay. What on earth? Where does psi get set? So this is the wrong. Oh no, this is right. So we want multi-coil. So what's the problem? Oh, I'm passing in an initial variable of the wrong size. a default indicator function, I think, should just say whether it equals 0 or not. Okay. We got a little farther. Right. Arrays of incompatible sizes. N is size 256 by 256 by 8. Norm's N is to size 256 by 256. What just happened? Arrays of incompatible sizes. Why? What was T? This is the reshape. This is the proximal operator, which has the parameter T. This is the second reshape. What's the problem? Norm's N is size 256 by 256. T is a number. Okay, seems to have worked. And we're running. With PhD, we spit out the parts of the objective value, and I'd like to do that. I'd like to be able to find a way to pass into PDH, to have PDHD with line search output, not only the values of the different components of the objective function, but also how much the constraint is violated. Okay, what size is Y? That looks a whole lot like just the least squares result to me. The interesting thing is that now we're not starting with the least squares result, are we? So here we're starting just with zeros. We're not initializing with the least squares result. And yet, we're getting basically the least squares result out. And what I don't understand is why isn't the compressed sensing doing anything? Okay, so something's clearly going terribly wrong because it's basically putting zeros in between the data points that were collected. These are the Fourier transforms of the reconstructed images, and it's clearly doing a terrible job of interpolating missing data. And if I change this to just prox L1, prox L1 complex, what does it do now? So now it's not doing joint sparsity, it's just doing individual sparsity. Norm L1. That should just be norm 1. So this is equivalent to doing this for each, well, this problem is equivalent to minimizing this problem individually for each coil. it's also doing a terrible job. Okay. It is, it is conceivable that we're just running nowhere near the right number of iterations. Maybe we need 10,000 iterations. So I'll check that off stream. But right now, as of right now, it's looking like there's a significant bug somewhere. I should be able to resolve this. Okay. See everyone later.